Hey everybody, David Shapiro here for a random video. Let me tell you what's going on. Okay, so there is an unmet need in our domain where we're trying to build artificial cognition and we need to rapidly experiment and we want to do vector search, embedding search. The problem is the only tools for this are all so there's Weaviate, which Weaviate, it allows you to store objects, but it's Docker only, which is, it's fine. Or I don't know if it's Docker only, but it's its own server. It's a whole server. Then there's FIAS, which is Facebook AI Similarity Search, which does vectors only. It's great. It's super fast. It can do 1 billion and it can do clustering. But it does not allow for any other context or data to put in it. It's only a component. It's not a fully fledged service. And then there's Milvus, there's Pinecone, there's a whole bunch of stuff out here that are like enterprise ready and cloud ready, but we're not there yet, right? I need something that is fast and disposable and lightweight, like SQLITE, but I need it for vectors. And that doesn't exist. So you know what I'm going to do? I'm doing VDBLITE. So vector database light. I'm going to do my own, and that's going to be hosted on PyPI. So I'm just documenting the process. I've written a module before. I just took it down because I realized it's super out of date. And you see, last updated 3 years ago. This was my proto Raven work, my proto AGI. So Meragi morphed into Raven. So it's been abandoned for 3 years. But I've done it before, so let's just get going and see what we can do. So the idea is it's pretty simple. We're going to do SQLITE, but for vectors. There's a lot of unmet needs. So, for instance, we need to, just keep it in memory, right? Just a memory-based vector search, disposable. Also writing it to file, right? That would be another great thing to do. So let's get started. First, I'll just copy my from Meragi. We'll save this in VDBLITE. So that'll be my setup thing, and this is what I use to setup.py. This is what I use to actually upload it to whatchamacallit. Wow, my brain is not working right now. To PyPI. There we go. Okay, so then we'll rename this to VDBLITE, and we'll do version, we'll just do 0.1. And description will be vector database light. And the URL, we'll take that out because the URL will be VDBLITE. Description equals long description, which will be, that'll come from the README. Long description content type text markdown. Author David Shapiro, author email. We're just going to say no1@gmail.com. I don't want you to know my email address. Packages, VDBLITE. Zip safe, false. Okay, I think that should be fine. So that's the first thing. But now we need something that'll actually work, right? Let me zoom in a little bit. So what is it that we're actually trying to build here? That is a good question. So I need to do some testing, right? What are the requirements? So let's just do some rapid prototyping. Let's do language, P, Python. Okay, so one of the requirements is in-memory vector similarity search. So basically, we just start something up, treat it like SQLITE, and then we need to be able to add stuff, so index them, and then retrieve them. I am not an expert. I have no idea what I'm doing. This is going to be usable. It's not going to be optimized, at least not the first version. If this takes off and we get people contributing, that'd be great. If we can get some people, doing this in C++, so that way it'll be faster, more optimized. That'll be great. Okay, but we need objects and or metadata attached to vectors. So what I mean by this is, like, in a relational database is basically just like a spreadsheet, right? So you'd have like row one, and then you'd have like text info here, and then you'd have a vector here, and then you might have like a timestamp, right? So I want to have this kind of stuff, right? We need to have an arbitrary amount of information with each record. Now, here's the thing though, because I'm doing AGI research, artificial cognition research, I need more than one vector to be stored with a bit of information. So for each item, for each object or record or whatever, what I need to do, so let's just say row two, there's gonna be an arbitrary number of information with it. So like, this will be, AGI memory one, right? It'll be stored like that. And then we'll have, whoops, vector one, which would probably be like 512 dimension similarity vector. And then I also want to store vector two, which might be a 2048 similarity vector. Because here's the thing, you want to have different levels of granularity that you can search because there's going to be different speeds, but you can also have vectors that have different purposes, right? And then I also want to have timestamps because all memory. So this is critical, absolutely critical. If you have nothing else associated with a memory, you need a timestamp because there's a temporal component in human memories, although the temporal component in our memories is all relative. So you say, I had, a ham sandwich on the same day that like the lightning storm soaked us on our hike, right? All of our memories are relativistic because we don't have a Unix computer in our head giving us a timestamp. But machines are lucky because they can have a number that says it happened at exactly this time. So then you might also want to have like file name. You want to have an arbitrary number of fields that are then associated with a given vector, right? So this is kind of the goal I'm setting for myself. Easy, right? All right. What do I know? What do I know that we need? The primary thing that we need is we're going to need import pickle. I'm just going to save this as a pickle. We could probably do cpickle for faster. I don't care. I'm not trying to optimize it. I'm just trying to get it to work. Import numpy as np, or whoops, numpy as np. We're going to do dot product similarity. There are better ways of doing this. So we're just going to do test.py. I have no idea how far I'm going to get today. Make sure that we're recording right. Yes, we are recording. 8 minutes in. Okay, so saving it saving it to file, that's going to be an option. It's not going to be required. Let me under Meragi init.py. Okay. And it's been anyone who watches my YouTube channel, that I'm like phobic of object-oriented coding. It's not that I don't like it; it's amazing. I just got out of the habit of doing it because of rapid prototyping. So I need to remind myself what I'm doing. That's fine. Okay. So we will come back here, do class server. We're going to change this. Instead of class, we're going to do VDB. One thing I do remember is that when you're declaring a class in Python, it is best practice to have the first one uppercased. I don't know if it might actually be a requirement. If it's not, it might not work. But I don't think you can do like VDB. It has to be uppercase V, lowercase db. Okay, so class server, def init. So we'll just copy a couple of these things. Ta-da! All right, we don't need a port. This is going to be local only. And then the fields, let's see. Field will probably have so actually from this, because the whole point of Meragi, microservices architecture for robotics and artificial general intelligence, the whole point of that was to serve as the heart, the framework of it. But I realized that it wasn't quite right, and so that eventually evolved to the current cognitive architecture that I'm working on. Okay, so we don't need the port. That's fine. And for the fields, I don't think we need that as well because stream of consciousness log. Yeah. Because this is just going to be, so let's just take that out. I might need to add it back. That's fine. Yeah. So when we declare this, well, I guess like SQLITE, it's kind of implicit. Um, yeah. All right. So we'll just say we'll start with an empty list. And so we'll call this the what'll this index would not be quite right. We'll just call this data. That's fine. And so basically what you'll do is once you declare your VDB object, you'll just do dot data append to add to it. And then once you're ready, then you'll do like an index or a search on that data. I think that's how we're going. This is going to be brain dead simple. Okay, so then let's see. Validate message. Result field equals message field. Return true result. Filter, HTML head, run. Oh yeah, this is the actual server. I could have sworn this was like for field in self fields. I don't know if this was complete. I might not have updated the latest code. Return true result. That was validate message. It's not actually storing any messages here, is it? Def run. Oh, here we go. What am I trying to remember how to do? New. Okay, here we go. Payload. Self validate message, self sock log. Okay, it is literally just that. Okay. So I think it'll be like def add. This is probably going to be a super boring video. I might not even post it. We'll see. Yeah. So validate message. All right. So validate message is when you add a thing. Okay. So we'll do validate or add, and that'll be self, and then it'll be, we'll just say payload. So the payload is a dict. And that's fine. And so then what we'll do, I think basically I'll do self.data.append payload. This feels wrong. I'm going to test this and it's going to blow up. Okay, so add, and then let's just do like our most basic search function. Def search self vector field. Yeah, that should be it. Oh, and then count. Okay, so this is where the rubber meets the road. Okay, so results equal list. And actually, I'll probably just copy paste the functions that I've used elsewhere. Did I do that here? Where did I use? Let's see, we need that. I'm not going to worry about, here we go, search index. Okay. That's basically this. Okay. So instead of results, we'll do scores. All right, for I in self.data. So that's our thing. And what we're going to do, so basically I want this to be really flexible. So I'm not going to assume that the field is going to be in every item, right? Because you might have different field names for different vectors and they might not be present in all of them. So I will say, let's see. We don't need to worry about that. So what we'll do is we'll do try score equals similarity, and we'll do I. So I, and then we'll do field. So you're basically saying search this field, this given field, and then compare it against a given vector that I want you to search. So that'll be good. And then the count is the number of results that you want to turn. So I'll just set that to default 5. Okay, so try and then accept continue. So basically what I'm going to do is if this field is not present, we're just going to skip it and move on. Otherwise, we're going to do scores append. And what we'll do is we'll do info equals I, and then info info score. So we're basically going to copy this record, and we're going to then add the score equals the score that we got. So basically, this will be the same exact item that was stored in it, and then we'll do scores append. So the scores is the results. Here, I'm going to change this to results because that's a little bit, yeah, that makes a little bit more sense. Results append, and then we'll just append info. So that should give us the results, and then what we do is we do ordered equals sorted results, and then we do lambda d for d score reverse true. So that'll sort it by top down, or descending order. And then what we do is we'll try and do ordered equals ordered. So we'll start from the 0 index and go up to count. So if you only want the top 5, it'll just say, okay, here's the top 5, send them back, and then we'll return I. Why am I doing that? I want to send back the whole thing. And so then so here's the thing. Sometimes you might be searching something that is very small, or the count that you want is going to be wrong. And so I want it to just send it back anyways. Okay. Is this ready for testing? Maybe it is. It still feels wrong. I've done something horribly wrong. I know that. Did I have a test in my old Meragi code? Meragi, init static. No, this is it. Dang. Okay. I could have sworn I had some test stuff in there. Yeah, so fetch, send. And then what do I do next? Okay, so then if name equals main, so then we say VDB equals VDB. Do I have to put the parentheses in? I don't remember. I don't think so. Let me look at the it's import Meragi server. Oh wait. Okay. Since it's declared here, where am I going? I think it's just this. Okay. So when it's instantiated, it's an empty list. Let's go ahead and add another function, def purge self, because I know this is going to be a function. So we'll do self.data equals list. That's fine. And then we'll probably need a save function. So that'll be pretty simple. Def save, and we'll do self and then file path. And that'll be basically all we'll do is just save the list. So we'll do with open file path, write binary as out file, and then we'll do pickle dot save. Let's see if I remember. It'll be self.data and then out file. Let me check the docs to make sure I did that right. Pickle Python tutorial. I'm trying to do all this from memory. It's been a little while. Sorry. Real Python. Da 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 da. Pickle dot save. No. Pickle dot dumps. Okay. Object file. Okay. Pickle dot dump. And then it's object file. Okay, so it's self.data out file. That's fine. That should be good. And then def load will be self and then file path. And then we'll say with open. Well, here, I'll just copy this. It's basically the same function. Pickle.load file. Yeah. So self.data equals pickle.load. And we'll change this to infile. Okay. Save, load, purge, add, search. We probably ought to have like a remove. So like del, so like def del, def del self, and then you'll say like, let's see, how do we want to identify? We'll say field and value. Okay, so whoops, def del. Oh wait, no, delete is there we go. Okay, so we'll say for I in self.data, try if I field equals value, a equals self.data. Wait, how do you do pop? Dot pop I think that's how you do it. Python pop list item. So that's pop the that index. Let's see. Python remove specific item from list without index. I think it's remove is what I want. The given very first element matching. Yeah. Okay, I think that's the one that I want to do. Yeah, so remove, it's just something that matches that. Okay, that's the one I want. So data.remove I. And it doesn't return anything, does it? Yeah, okay, so we can... So if it matches, and then if that whole thing fails, we'll just say except continue. Whoops, we don't need to duplicate that. Continue. And so this will delete everything that matches that specific value. So if you have a vector or a timestamp, so that'll be one of the best ways. So with a Unix timestamp, there's so much precision that that you can basically treat a Unix timestamp as a UUID. Not always. It's entirely possible that you'll get something at the same exact time, but let me show you how precise this is. Let's see, from time import time. And so then you just do time, and you see it goes out to 1, 2, 3, 4, 5, 6, 7. 7 precision. So that's let's see, that's millionths of a second. So that's pretty darn precise. The likelihood of getting two exact timestamps that are identical is very low. It's non-zero, right? It can still happen. Whereas so originally what I would do is let's see, from UUID import UUID4, I think, and then so then you do print string UUID4, and so what you can do is UUID v4 is universally unique identifier version 4. there are enough UUID v4s that you can address, I think, every atom in the universe. Um, and so every time you run this, it is pretty much guaranteed to be unique in the entire existence of all of history. So if you want something that is guaranteed to be unique, use UUID 4. It's quick and easy, and you can see there's no real pattern to it. Um, it's not like a burned in address. It is, there's a lot of stuff going on behind the scenes to ensure that it is pretty darn random. But, there's also nothing wrong with just using time. For our intents and purposes, time will suffice. Yeah. So if you pass in a field, like, if this is like, um, if field equals time or timestamp or whatever it is, then we'll just say timestamp. Then value might be, and we'll just copy paste this. So you're guaranteed to be like almost guaranteed to be 100% unique. Let's see. Let's do first only equals false. And so then what will happen is, so then we'll do a test if first only, and so this is implicitly true. If first only, then we'll just do return, which means that, like, okay, delete only the first one. So we'll have this function available to us in case we want to only delete the first one that matches. Ideally, in the future, we'll have multiple things that allow you to delete something, but for our intents and purposes, we'll use timestamp as the equivalent of our UUID. That'll allow you to zero in on one. You can also always add UUID back, right? There's nothing preventing you from having UUID could be in the payload, Use it if you want. I think it's up to you. And then you have whatever vectors will have your similarity. Okay, so so now we need to load this up with something. What do we load it up with? Let's do. Let's go look at the FICE. Let's see. Towards data science FICE. Yeah, here we go. So this woman wrote a really great write-up of FICE. It turns out FICE doesn't do what I need it to do, but we can do a couple of good things. So let's see, np random seed. We want vectors as type float 32. All right, so we're doing how many dimensions? So there's going to be 200 by. All right, let me zoom in so you can see what I'm looking at. All right, so this is using NumPy to generate some random numbers, and we'll just do this as like a way to test this. Okay, so I'll just copy this because it's useful. Borrow code. All right. But I don't have a function that can do them as one. So we will do, I don't know off the top of my head how to split up how to split these up as individuals. So we'll do n1, and then let's just print db vectors, and the dimension will say 12. All right, let's see if that works. I might be completely losing my mind. cd VDBLITE Python test. Okay, that worked. Okay, so we've got a couple of vectors, dimension as type. Can I just do the 0th one? Does that work? Oh, okay, cool. So then let's go ahead and let's do 200, because then I think, okay, cool. And if we print out all of them, so you can treat this as a list of lists. Okay, that's fine.
That's fine.
All right. So then what we'll do is for vector in DB vectors, we will do info equals, we'll say vector equals vector, because I'm not creative like that. And then I want like some random, oh no, we'll do from time import time. And then from UUID import UUID4. Bingo! Okay, so then we'll do time equals time. And so that'll be stored as a floating point number. You can also store these as decimal. I can't remember. There's a way to store numbers in Python as like literals, literal numbers, not floating point, as decimals. It's not that important. And then we'll say UUID equals string UUID4, and that will be what we're going to register to the vector. Okay, so then we'll say VDB.add info. Yeah, that should work. Let's run this and see if it blows up. And if this works, I'm going to like save this video and just be like, we're done for now. Because quit while you're ahead. Okay. Let's add a function. So def details self. And so then we'll just do like print db elements number, and then we'll say len db no self dot data. And then what else? There would there's a way to show like size in memory. Python show size in memory of list. Import sys size get size of. Okay, sure, let's do it. Import sys, and then we'll say print db size in memory, and we'll do what was it? Sys get size of. Is that right? Yeah. List one size of. Get the size of the list using. Oh, interesting. But why are they different sizes? Okay. We'll do sys, because I think the system reporting the size of it is probably going to be more accurate. Okay, and instead of list one, we'll do self.data. Sure. And then at the end of that, we'll do vdb.details. And let's see, CLS. It's working. It's really working. Okay, so that I think is in bytes. Yes, so that returns bytes. So let's add a thing in here so that it's clear what we're talking about. We'll do just bytes. Bytes. There we go. I can spell. Okay, and then the last thing we want to do is just search. Let's do a search. So we got the details. Here, let's comment out. We'll just do the first one. And then let's do results equals vdb.search. And let's see, how did I define the search? So we give it a vector. So let's do db vectors, and this is going to be like an exact match, right? But let's find, so let's do the 10th vector, and then the field name um, is just vector. Here, let's actually make that implicit. So field will just equal vector unless otherwise specified. And so then also the count we'll leave that implicit as 5, just because you never know, you might have just one. Okay, and so then let's get from pprint import pprint as pp, and then we'll do pp results. Let's see what happens. It returned nothing. It was too good to be true. Let's see how long this video is now. We're only at 35 minutes. Let's see if we can figure out what's going on here. All right, I suspect, so here's why you don't want to do try except, is because it will often exception as oops. So we'll do print oops. Because you'll often end up with something that you don't want. So let's see, where all did I use try? Pretty much just in the search loop, and then here. I haven't tested the delete functionality yet. Okay, so let's see. Name similarity is not defined. What do you mean it's not defined? Oh, right, because I copied another thing and I had a function named similarity. But we can replace that with np dot dot. I don't know why I have this as a separate function. I thought it was going to be more complex than that. Okay, that's fine. All right, so where is similarity? There it is. Okay, np dot. So now we should be able to, well, here, let's leave that there just in case it blows up. CLS, Python. Oh, hey, look, we have similar things. Vector array. Oh, interesting. Okay, so it stored it as a NumPy array in memory. I wonder if that's more efficient than storing it as a list. Who cares? But you see, it's sorted. So this whole thing worked. It worked. Cool. I'm going to save this on PyPI, and you'll be able to use it. And actually, you know what? Because this works, I'm going to go ahead and get this registered on PyPI and then show you how to use it yourself. So give me just a smidgen of time. Okay, it's up on PyPI. Look at this. Yee. I did good. Okay, let's give it a test, make sure it works. So we will do pip install VDBLITE. All right, and now let's make sure that this little script that I wrote works. This is the public test version. So we'll do Python, we'll do pub test.py. And then we'll just jump in here and do Python pub test. NP is not defined. Did you mean PP? Well, darn it. From no, import numpy as NP. Now that should have been in here. Okay, whatever. Let's see what happens. Pub test. Time not defined. Do I? Oh, I think I need to. I don't remember how to do this. There's a way to tell it to import everything that it needs. I don't remember how. Okay, so there might be a small problem. Setup, get ignore, readme, Meragi, edit. Yeah, because if you import all these in the init, all right, I'll look it up later. Important thing is, I know that you need to import all these yourself. And we will figure this out later. Import VDBLITE. Okay, so let's try this again. Ta-da! Look how fast that is. All right, I will call this a day because that worked. All right, thanks for watching.